The substitution method. Objectives. By the end of this lesson, you should be able to evaluate a limit using the substitution method when applicable. So one of the reasons we develop continuity is so that we can apply the substitution method for evaluating limits. So this says that if we have a function that's continuous at x equals c, then the limit is just equal to the function value. So in other words, the limit as x approaches c of f of x equals f of c. So we can evaluate a limit by now just substituting x equals c into the function. So just plug in x equals c, provided we have continuity at c. And this is a lot easier than the previous methods we've been using, like the numerical approach of finding a table or graphing the function in order to analyze it. And this is going to give us an exact answer. So let's just do a few examples. So in this example, I want to evaluate the limit as x approaches negative 2 of x squared plus 4x minus 9. So the first thing we have to remember is that x squared plus 4x minus 9 is a polynomial. So it's one of the known continuous functions that's continuous everywhere in its domain, and its domain is all real numbers, so that includes negative 2. So now, applying the substitution method here, we have that this limit is the same as just taking the negative 2 and substituting it into the x values. So negative 2 squared plus 4 times negative 2 minus 9. So we'll get 4 minus 8 minus 9. So this is going to become negative 4 minus 9. So our limit is negative 13. So because this is a continuous function everywhere, negative 2 falls in that domain. So we can just go ahead and substitute negative 2 into the x values and get out our limit value. So the limit value equals the function value. In this next example, we want to evaluate the limit as x approaches pi over 2 of cosine of 2x. So this is going to take a little more reasoning to show that cosine of 2x is continuous. Well, cosine x and 2x are each continuous functions, and this is the composition of cosine x and 2x. So because it's a composition of continuous functions, it too is continuous. So now we can apply the substitution method. So we're going to take pi over 2 and substitute it into x. So this is cosine of 2 times pi over 2, which is the same as cosine of pi. So the 2's are going to cancel. So cosine pi, let's draw ourselves a little unit circle. Pi is over here at this coordinate point, negative 1, 0. Cosine is the x value. So cosine of pi is negative 1. So we just went ahead and substituted pi into cosine 2x because cosine 2x is continuous on its domain. And the domain of 2x is all real numbers, the domain of cosine x is all real numbers, and the composition of continuous functions is continuous.